In section 4.4, we're going to be looking at logarithmic properties. So some more properties that we can grab from what we're working with in these previous sections. And so the first property we want to look at is called the exponent property. And so as we work through these properties, I want to show you how it works with logs. Same thing with ln, remember that's just base e, and then do some examples, and then do another property and go from there. And so these properties are really nice because it gives us a way to rewrite how a logarithmic is written so that the end game, we can solve these out. And so the exponent property says this, that if you have an exponent right here on your log, that you can actually bring this out front and turn it into a coefficient or a multiplier. So it becomes a regular size looking r log base b of a. And this is being multiplied by that log. The same is going to be true for your ln, so you can take this r, this exponent, and you can bring it out front and becomes just regular written r ln of a. It's no longer really small written up there in the top. And again, that's being multiplied. And so let's look at some examples. It says simplify using the exponent property. Well, you can see in the first one, we don't have an exponent. So I'm going to rewrite it as an exponent. So that's log base 3. Instead of 25, let's call it 5 squared. Now that we have that exponent, we can take it and we can move it out front. So it gives me 2 times log base 3 of 5. And that's all it wants me to do with it, is just rewrite it. Now this next one is already set up for us. We can see that it has an exponent. Has an exponent right here. So I'm going to bring that out front. So I'm going to say 3 ln 7. So I'm just rewriting these based on this exponent property. I'm not doing anything else to them. The next one, you can see that it has a 1/3 right here. And so if I bring that out front, that gives me 1/3 log base 5 of 25. But we already saw in that previous one, 25 could be written as 5 squared. So I'm going to rewrite that 1/3 log base 5 of 5 squared. And now I can bring that 2 out front. So it gives me 2/3 log base 5 of 5. But remember here, in those previous properties in the previous section, we said if these numbers are the same right here, that is actually going to cancel out and give us 1. So this is 2/3 times 1, which is 2/3. So in this problem, look at the instructions. The instructions say simplify. So if I'm simplifying, I want to simplify as much as I can. So I had to apply that exponent property twice. I started to see something that looked like what we did in the previous section. I changed it to a 1, and I was able to simplify this all the way up into a 2/3. Let's look at the next one, ln of 1 over x squared. Well, remember properties of exponents from Algebra 1, you could bring that up, and that would be ln of x to the negative 2. And then exponent property of logs, I could bring that out front. So I get negative 2 ln x, and that's my answer. We're just rewriting stuff. Next one. If you remember from previous courses, this cube root right here can be written as log base 5 of 5 to the 1/3. So then I could bring that out front. It gives me 1/3 log base 5 of 5. And then that's that inverse property again. So I get 1/3 times 1, or 1/3. So pretty neat stuff that you can do with your exponent property. We can rewrite them, or we can even simplify them down to this 1/3 that we have. The next property we're going to look at is the product or the sum property of logs. And what the product and sum property of logs says that if I have 2 logs of the same base b, and they're being added, I could condense that down and call that log base b, that's what they both had in common, of a times c. So this addition, when condensed down, now becomes multiplication. And then you can see that when I go to quotient and difference, similar process. They're both log base b, and we're just subtracting the same logs, so that would be the same thing as log base b of a divided by c. So your addition becomes multiplication, your subtraction is going to become division. So this gives us a way to condense down problems, or possibly go the other way and expand problems. So let's see how we can make this work for us. And so it says examples, expanding and condensing. Write as a single logarithm or condense. So you'll notice they're all log base 3. And so I'm going to condense this down together. So this would be log base 3. Addition becomes multiplication, so it would be 5 times 8. Subtraction becomes division, divided by 4. So that would give me log base 3 of 40 over 4, which is equal to log base 3 of 10. And so I was able to take this all these logs being added in subtraction, condense it down, and get a singular log of log base 3 of 10. Next one says, write a single log. So let's combine this together with our exponent rule. So I'm going to first bring all my exponents back up. I'm going to reverse that. So if I have a number out front here, it becomes the exponent on the x. I have a number out front here, it's going to become the exponent on what I'm logging. So I'm going to say log of x to the 1/2 plus log of x plus 1 to the 3rd. Addition becomes multiplication. So I can write log of x to the 1/2 times x plus 1 cubed. And lastly, that 1/2 we know is actually the square root of x. And so that would be my singular log. Now note, when I'm writing a single log, I only write log once. Now when you learn this in the homework, you might have to put an additional parentheses around everything that you're logging. So that one combined our exponent property with this condensing property. So let's do it again. First, you want to take your large numbers in front of your log and move them up and become your exponents. So I'm going to take this 2, I'm going to move it up here. So this becomes ln of x plus 2 squared minus ln x. If I'm subtracting 2 logs of the same basis, that becomes division. So I have ln of x plus 2 squared all over x. I'm going to put an extra parentheses around what I'm logging, and that would be condensed to a single logarithm. Now the next one's a little bit different because it doesn't say just write or condense to a single log. It says evaluate without using a calculator. So I better get a pretty nice number here if I don't have to use my calculator for it by rewriting as a single log. So first I'm going to bring the coefficient up. So I'm bringing this 2 up to the 5. So it gives me log base 5 squared plus log of 4. Then remember, addition is your multiplication. So I'm going to say, well, that's log of 5 squared times 4. So let's see, that would be log of 25, 5 squared times 4. So log of 100. And then remember, when it doesn't have a base written there on log, it's a base 10. So let's set this equal to y and let's snail it and actually solve it because it says evaluate. So I should get a number. So if I snail that around, it gives me 10 to the y equal to 100. Our 1-to-1 property says that if this is 10 to the y, I could rewrite this as 10 squared. And I can set those exponents equal. So my final answer is y equal to 2. Now look at that problem. It went kind of quick. It went kind of quick. I get that. Here was your exponent property. Here was your condensing property. I just multiplied. Then I changed from a log to an exponential in this step. And then this is my 1-to-1. So it's pretty neat on how I can really put all this together, create singular logs, and be able to evaluate. Now, if I lost you a little bit on that, I would recap, go back to the beginning, kind of go a little bit like pause it, write it, pause it, look at it, make sure you're understanding those steps. If you need additional help, feel free to reach out to me through Canvas messaging. Let's do a few more examples and then we'll be done. Number 5 says rewrite as a sum or difference. And so what we're going to do is we're going to expand it out. So we're going to reverse those steps that we were just doing to create that. So I'm going to say, okay, ln of x to the 4th y over 7. I'm wanting to expand this out. Well, the first thing I want to do is I want to get rid of the multiplication and division. Remember, that creates addition and subtraction. So I would say ln of x to the 4th plus ln of y minus ln of 7. And I was just applying that multiplication becomes addition and division is subtraction. And then I'm going to take any exponents and bring them just in front of the logs that they are and create them as coefficients. So 4 ln x plus ln y minus ln 7. So now I have expanded it out, and in those previous examples, this is what we were looking at and rewriting it as a single log, and so now I'm going backwards with it. Let's do it again. This says rewrite as a sum or difference of logs. So first, let me go a little bit slower. I want to get rid of, I want to get rid of this division. So I'm going to say ln of the square root of 3x minus 5, division becomes subtraction, ln of 7. So now I'm having to write ln more. Next, I'm going to rewrite that radical as a fractional exponent. So ln of 3x minus 5 to the 1/2 minus ln 7. And then I can take that exponent and bring it out front. So you can see when I'm condensing, I deal with the exponent first. When I'm expanding, I deal with the exponent last. So it gives me 1/2 ln of 3x minus 5 minus ln of 7. And that's my final answer. Now the next one, let's bring it all together. These last two, I'm going to show you how to kind of use all your properties in order to solve, because that's our goal, right? We got to solve. It says evaluate without using a calculator. So you better show me some work. So with this one, I want to work it two different ways for you. First way, you're in this mode of condensing and expanding. Remember, subtraction becomes division. So this would be ln of e to the 6 over e squared, written as a single log there. Well, if you remember properties of exponents from Algebra 1, when you have the same bases in your division, you subtract those exponents. That gives you ln of e to the 4th. By your exponent property, this 4 could be brought out front, so it gives me 4 ln e. And then remember, this is the inverse property of natural log, and that's equal to 1. So it gives me 4 times 1 equal to 4. Now here's what's really neat about logarithms. You can actually work these a couple of different ways. And so let me show you another way that works really nice, and you're going to like this way. And instead of condensing it down, let's take ln e to the 6 minus ln e squared. Remember when I talked about ln e is like line, like a line? This is equal to 1 by the inverse property. This is equal to 1 by the inverse property. So really I have 6 minus 2, and that's 4. And both of these steps would give you full credit on an exam. And so logarithms are really nice because based off their properties and how we can manipulate them, we could actually work it quite differently, still applying properties mathematically correct, and get the same answer. Last one, this one would be a really good problem for us to kind of pause on what we're doing here. Let's look at condensing this and solving this. So it says solve the following equation. ln of x plus 2 plus ln of x plus 1 equals ln of 4x plus 14. So the first thing I'm doing is I'm going to condense it, and I'm going to condense this plus sign. So that would give me ln of x plus 2 times x plus 1 equal to ln of 4x plus 14. Now by your one-to-one property, we've learned that if you're ln-ing two different things, but they're set equal, that by your one-to-one property, you can just set what you're natural logging equal to each other. And then we can go from there. So now I'm just solving for x like previous sections, not even in this chapter 4. So I'm going to square this out. This gives me x squared plus 2x plus 1x plus 2 equal to 4x plus 14. Combine like terms, x squared plus 3x plus 2 equal to 4x plus 14. I see I got a quadratic, so I better get it all over to one side and say it equal. So if I subtract that 4x and subtract the 14, that gives me x squared minus 1x minus 12 equal to 0, and then I can factor. So it gives me x and x. My signs are going to be different. And I think what will multiply to give me negative 12 and add to give me negative 1, that would be negative 4 and positive 3. Set both those equal. I get x to be negative 3 because x plus 3 could be 0. X minus 4 could be 0, so x is equal to positive 4. And so all of this is from previous sections of solving a quadratic. This step is condensing. This step is the one-to-one property. So you cannot forget all that you have been doing and solving up until this point. We're still going to be able to apply it here. So let's continue with our solving. It says solve equation using log properties. If you have a logarithm on one side, here's my tip. You want to turn the equation into an exponential equation by exponentiating both sides to the same base. Let's look at some examples and see what that even means. I hope I didn't lose you by just saying that. So here's what we're going to do. It says solve the equation. And you can see in this one, it doesn't have log on both sides. We can't do one-to-one property. It doesn't have anything to expand out or condense. So here's what we're going to have to do in these examples. We are going to have to think, what have I learned about logarithms and exponentials? And think about those properties. Think about those processes. Then we're going to have to look at it and see, what could we do? So the first thing I want to look at and say, okay, it says log equal to 3, log base 4 of 2x minus 6 equal to 3. And I go, I can't do one-to-one property. But I could snail this around and change it into an exponential and go from there. So I could start with the 4. I could snail it around. Excuse me, I got a little jumping going on there. And so I could say, when I work this out, I'm going to start at the 4. I'm going to come around here. I could write that as 4 to the 3rd power equal to 2x minus 6. Then I could solve it out from there. Well, 4 cubed is going to be equal to 64. That's equal to 2x minus 6. So I could add 6 to both sides to give me 70 equal to 2x, and then divide by 2. So x is equal to 35. Now, I've already told you that working with logs, you could do it one of 2 different ways. So let's do it again. I want to show you another really great way that you can look at it, and that's going to back to those words that I just said. So let's exponentiate both sides. So let me show you this on how I can apply inverse property in order to solve this. If this is a base 4, from our inverse property, we learned that if this was a large 4 right here, these two would cancel. Well, basics of solving for x back in Algebra 1, whatever you do for one side, you have to do for the other. So if I want this to be a large 4 on the left, I'm going to raise, I'm going to raise both sides to a large 4. So on here, this would cancel, but over there on the right, I just end up with 2x minus 6 equal to 4 cubed. And notice I'm back to what I did over here. And again, I would get x to be 35. Both methods are correct. The right side uses your inverse property. The left side uses that Snell method. And so I want to expose you to these different methods because we're all different. We may see it different ways. But as long as you're mathematically correct and showing your work, you're going to receive full credit. Let's look at the next one. It says log of 50x plus 25 minus log x is equal to 2. So the first thing I'm going to do is I'm going to condense first. And so I'm going to say, okay, well, subtraction is division, so that would be log of 50x plus 25 all over x is equal to 2. And then from there, I'm going to say, okay, I could Snell it, but let me try that new way. If it doesn't have a base, it's an assumed, sorry guys, it's an assumed base 10. So I'm going to raise both of these to the power of 10. This is the inverse property, so I would just be left with 50x plus 25 over x. And over here, 10 squared would be 100. And then I could solve from there. So in order to get rid of division by x, I would multiply both sides by x. So that gives me that cancel. So I'm left with 50x plus 25 equal to 100x. And I just got to combine like terms and solve. So subtract 50x. I get 25 equal to 50x. And divide. So x is equal to 1/2. So you can see right here, when we raise both sides to the power of 10, we were able to apply that inverse property and then just solve for x like we know how to do. One more, and then we'll look at some different examples. It says solve the equation. Now, whenever you do this, here's what I would do. First, I'm going to isolate that logarithm before I do anything. So I'm going to say, ooh, sorry about that. I think my computer's saying quit. I'm so over this. Hopefully you're not. Let's finish this up. So solve the equation. 4 ln of 5x plus 5. So the first thing I'm going to do is I'm going to subtract 5 to move that plus 5 over. So I get 4 ln of 5x equal to -3. And then I'm going to divide both sides by 4 to get rid of that division by 4. So I get ln of 5x equal to negative 3/4. Now that I have the ln isolated, I'm going to show you a neat little thing here. So exponents, this is a base e. So if I e both sides, this is like line I told you, those are inverses. So this gives me 5x equal to e to the negative 3/4. Great, that's a button on my calculator. And then I could divide by 5. So it gives me x equal to, go in your calculator, e to the negative 3/4, enter. Divide it by 5, enter. So approximately 0.0945. So you can even use that exponentiating both sides there, or raising them to a power of a base, to help us with a natural log. Now again, you might be like my computer and glitching out a little bit. This is a pretty long lesson. But I want to kind of keep solving. I want to do a few more examples and give you a good basis, because we're just putting everything together. This is kind of the section where you're putting all of your properties and notes together. So I got 5 examples left. Hold tight. We'll get through this. It says if you have an exponential expression on one side, turn the equation into a logarithm by taking the log of both sides. So you know what? When in doubt, log it out. So if you're not sure what to do, try logging both sides and see if that gets you anywhere. The first thing I'm going to do is I want to isolate though. When I isolate, I'm going to divide both sides by 3. When I divide both sides by 3, there we go, that's a little bit better. That gives me 2 to the x equal to 42 over 3, which would be 14. Now, what I want to do is I want to log both sides. So if I log both sides, I get log of 2 to the x equal to log of 14. Properties of exponents say that I can bring that exponent out front. So it gives me x log of 2 equal to log of 14. And then I could divide both sides by log 2 to get that x by itself. So x would be equal to this value here. I could punch that in my calculator and it gives me 3.807. Now what's really neat about this one is we could work it another way. We could also work it and we could consider maybe taking the log base 2 and look at it from there. So I'm going to do it again, but I'm going to start with that 2 to the x equal to 14. So in the previous problems, we would do the same as the base of the log. So let's do the same as the base of this exponential. So I am going to, sorry about that, I'm going to log base 2 both sides. This creates an inverse property here, so that's x equal to log base 2 of 14. Using your change of base formula, you could say log of 14 divided by log of 2. We talked about that change of base property. And look again, I'm at log of 14 divided by 2, so I still get 3.807. And so again, multiple ways to solve these. Go with those properties that you're seeing more readily. Let's look at the next one. I just want to expose you to multiple examples here so you can see what all could you do. Solve the example. Well, first thing I want to do is I want to try to get that x by itself. And so I'm going to go ahead and I'm going to subtract 5 from both sides. It gives me e to the x equal to 55. Whenever I see a base e, I like to apply my ln. So I'm going to ln both sides. ln e, that's an inverse property that cancels. So I get x equal to ln of 55. Look at that. We got that. And so you type it in your calculator, it gives you 4.007. Now, ln 55 is a very base number. And so that's an exact number. You could use it. Or we could type in our calculator and do 4.007. Just base it off your instructions given on the problem. If they say round to a certain amount of decimals, they're wanting that 4 number. If they say nothing about rounding, ln 55 is best. It's exact, unrounded. Next one. Solve the equation. Okay, let's start moving things and try and isolate that exponential. And so I'm going to say, so I'm going to say plus 4. So it gives me 3 times 3 to the 2t minus 5 equal to 15. Divide by 3. So 3 to the 2t minus 5 is equal to 5. Now that I have that exponential by itself, I got some options. Now I'm going to do that inverse property again. And I'm going to do base 3 since that's a 3 base on my exponential. And so I'm going to say, okay, well then that would be log base 3 on both sides. Would cancel to give me 2t minus 5 equal to log base 3 of 5. I'm going to add 5 to both sides. So it gives me 2t equal to log base 3 of 5 plus 5. I have to use that change of base formula, so let me come up here. So that would be 2t equal to log 5 over log 3 plus 5. Plug that in your calculator, and then once you get that number, we're going to divide the whole thing by 2. You're going to have to use your calculator as we're working on this to get these exact, these decimal numbers, and we get 2.232. Now, that looked a little complicated. I think we could do that a little bit better. Let's come over here and let's do that a little bit better, and let's use our LNs this time. So I'm going to start back to where we got it to be an exponential. So I'm going to work with 3 to the 2t minus 5 equal to 5. I want to LN both sides. I love LN in both sides. I feel like things work out really nicely. So I'm going to say LN of both sides. Now, if that gives me 3 to the 2t minus 5 equal to ln 5. Rules of exponents, I could bring that out front. So I get 2t minus 5 ln 3 equal to ln 5. Well, this is being multiplied over here. So I could divide by ln 3 on both sides. That gives me 2t minus 5 equal to this value. I can plug in my calculator and then add the 5 to it. Whatever that value may be, don't round to the very end. And then divide by 2, whatever that value is. So you can see similar steps, but now we're working with the natural log, and maybe that looked a little bit better for you. 2 more, we'll wrap this up. Next one's a really nice problem. I like to bring that up on the exam because this one, we're going to work with our e's, but we're going to factor it. So this is really nice because let's think about how we could factor this and break this apart. And then we'll apply some of these inverse properties. So this kind of looks similar to a quadratic. So I'm going to say, okay, well, let me treat it like a quadratic. I'm going to factor it. What will give me e to the 2x? Well, actually, e to the x times e to the x is e to the 2x, because when you multiply those together, you would add the x's to give you a 2x. Now the back sign is negative, so it means they're going to be different signs. And then I think what will multiply to give me negative 3 and add to give me negative 2, and that would be a negative 3 and a positive 1. You keep on solving like you know how to do with the quadratic. So e to the x plus 1 is equal to 0. So e to the x is equal to negative 1. Now I need to get that x out of there. So the inverse property of e's is ln. So I'm going to ln both sides. It gives me x equal to ln of negative 1. Now, when you go to ln negative 1 is not in the domain of our natural logs. And so that is actually not going to work out. But let's look at that e to the x minus 3. So I add the 3 over. ln both sides to cancel the e, so you get x to be ln 3. Exact answer there. Or plug it in your calculator, 1.099. So I like to do that one because I feel like it relates back to some of the solving that you did with your quadratics. Last one. I know you're probably tired already. Who wants to watch a math video for 30 minutes? But I wanted to give you a bunch of examples to help you with this homework. Now this one's fun. Make sure you have some room on your paper. These are not the same bases. And so this one's kind of going to be a fun one for us to see how we can put it together. And if you're lost a little bit in the previous ones, let's just kind of work through this. Once you do the homework, come back and view this one. What I'm going to do is, this is not the same basis, so I cannot set the exponents equal to each other and use my one-to-one. So what I'm going to do is, I'm going to ln both sides so that I can pull those exponents out in front. And so I'm going to say ln of both sides. So ln of 7 to the 3x minus 7 is equal to ln of 9 to the 7x minus 5. By your exponent property, I can pull these out front. So that gives me 3x minus 7 times ln 7 equal to 7x minus 5 times ln 9. So I was able to pull those letters out of the exponents. Now I'm going to distribute this in here. So this gives me 3x ln 7 minus 7 ln 7, just multiplying those together, same thing here. 7x ln 9 minus 5 ln 9. Now our goal is to solve for x, and so what I'm going to do is I'm going to get everything that has an x on one side and everything that doesn't have an x on the other side, because these two numbers right here, these are just numbers. I'm going to use my calculator, I'm going to get those, but this has an x in it and this has an x in it. So I'm going to subtract this one to move it over here, and I'm going to add this one to move it over here, and that gives me 3x ln 7 minus 7x ln 9 equal to 7 ln 7 minus 5 ln 9. Whew! Over here, you see on the left-hand side that they both have this x in common, so I'm going to factor that out, because this is 3 times x times ln 7. 7 times x times ln 9. So it gives me x 3 ln 7 minus 7 ln 9 equal to 7 ln 7 minus 5 ln 9. I'm just bringing that down. My whole goal, let's solve for that x right there. So now that I have it factored out, I could divide, I could divide by that whole grouping. So I get x equal to this big old grouping right here. I'm going to slowly type that in my calculator. I'm going to type this part in here, 7 ln 7 minus 5 ln 9. Make sure that you're putting parentheses around this number here, that you're only natural logging that, and hit enter. Divide it by, so it's going to take your answer, divide it by this, and again, make sure you put parentheses around whatever you're logging or natural logging. This will give you negative 0.2761. Now all this was a beast to solve, quite in depth. This kind of problem right here is the reason we need those log properties in order to solve it. So this definitely is the high point of this section, is putting all that together and being able to solve something like this. But don't be scared. Go back through it. Work all that you can do. Contact me if you have any questions along the way. And then go and try one of these, putting your skills together. You got this. Contact me if you have any questions.